Why hello there, I sensed you'd be watching this video soon. In fact, I sense the force is growing stronger in you. There are only a few things left for me to teach you before you are truly a Jedi and ready to keep balance in the force and in equations. Today's topic, we're looking at numbers of solutions. If you look down here, you see two different equations. 2 equals 5? What, you may say? That's utterly nonsense, and you are correct. What about 4 equals 4? Well, that makes sense. That's obvious enough, right? Duh. Okay, so we're going to kick these up a notch. But today I want you to be thinking of what makes sense, what doesn't, and we're going to determine whether or not and how many solutions an equation has. So there's 3 different scenarios I want us to consider. Don't worry about writing this down. Just try to follow along with my logic as I go over each one. Let's start with this guy right here. X plus 2 equals x plus 2. Well, that seems like it makes sense. X plus 2 has to equal x plus 2. In fact, let's say we tried to put our variables together. If I subtracted x from both sides, I'd get my x's cancel here, my x's cancel here, and I'd get 2 equals 2, which is a true statement. That makes sense as well. Let's say I plugged in x equals 1. That would give me 1 plus 2, plugging that 1 in for x, equals, and then instead of x, I'm going to put 1, then I still have plus 2. That would give me 3 equals 3. That makes sense. So x must equal 3, right? Well, what if I plugged in x equals 2? Instead of x here, I'm going to put 2 plus 2 equals, and instead of x, 2 plus 2. That gives me 4 equals 4, which is also true. So which one is the solution? Is it x equals 3? Is it x equals 2? And in this case, really, we could plug in absolutely anything. Whatever number we plug in for x, x plus 2 will always equal x plus 2. And we call this case infinitely many solution. This means that any x value will work. Our next case is x minus 1 equals x plus 5. Now this should be a red flag. Can x minus 1 equal x plus 5? That's a little fishy. Let's say we subtract x from both sides to get our variable to the same side. These will cancel out. These also cancel out, and we get negative 1 equals 5. That is definitely not true. That is not going to work. Let's just try some values. If we plug in x equals 1, that's going to give us, instead of x, 1 minus 1 equals, instead of x, 1 plus 5, which would be 1 minus 1 is 0, equals 1 plus 5, 6, which is also not true. In this case, no matter what we plug in, it doesn't make sense. X minus 1 will never equal x plus 5. We say that this equation has no solution, which just means that no value for the variable will ever work. In our last case, we have 2x minus 1 equals x plus 3. Okay, well, I don't have any initial thoughts, so let's see what happens if we try to solve this. Let's combine our variables to one side. So I'm going to subtract x from the right, subtract x from the left. Those are going to cancel out. Then I have 2x minus 1x, or 2x minus x, leaves me with x minus 1 equals 3. Then I could add this one over here, add this one over here. That's going to cancel, giving me x equals 4. So this has a solution of x equals 4. If I took this and plug it back in here, that's 2 times 4 is 8, minus 1 is 7, equals 4 plus 3 is 7. We can test that and see that that works out. Any other x value that I plug in is not going to work for this. This only has the solution x equals 4. In these cases, we say the equation has one solution, which means only one value will work for the variable. Let's take a closer look at each of these and look at some clues to make them easier to spot when looking at equations. First up, infinitely many solutions. This means all values will work. Our clue here is that the equation is exactly the same on both sides of the equal sign. Let's look at a couple examples. Here we have 3x plus 4 equals 3x plus 4. This is infinitely many solutions. It is always true. 3x plus 4 always equals 3x plus 4. What about this one? 1 minus 10x equals negative 10x plus 1. Although these look a little different, all we did here was switch the 1 and the minus 10x. So instead of having the minus 10x here, we have minus 10x here, or negative x. Instead of having the 1 here, the positive 1, we have plus 1 here. So all those terms did was switch, but they're still exactly the same. So 1 minus 10x will always equal negative 10x plus 1. This one is also an example of infinitely many solutions. Next up, no solution. This means that no value will work. Our clue here is that the same variable term is in the equation, but different constant terms. For example, in this equation down here, we have the same variable term, 2x and 2x on each side of the equation, but we have different constant terms, 1 and 7. The constant term is just the term without a variable. So since we have the 2x and the 2x the same, but the plus 1 and the plus 7 are different, this is no solution. And that might make sense to you. Can 2x plus 1 equal 2x plus 7? No way. This is no solution. Over here, we've got the same variable term. That's negative 7x and minus 7x. It's okay if they're switched around. Negative 7x and minus 7x, that's the same. But this minus 13 and this 5 are not the same. So we have negative 7x minus 13 will never equal 5 minus 7x. This is no solution as well. Lastly, let's look at one solution. This means that only one value will work. Our clue here is when there are different variable terms on each side of the equation. This one I think is the easiest to spot. If I look at my variable terms here, on the left side I have 3x, but on the right side I have 5x. Since these are different, it means that this right away is one solution. It doesn't even matter about the outside constant terms. Looking at this sample over here, we've got on the left side a 12x, and on the right side a minus 4x. Again, because these two x terms, these variable terms, are different on the left side and the right side of the equal sign, this is one solution as well. This has been Training with Jedi Zonker, but before I leave today, I've been receiving some complaints that I haven't been using enough Star Wars puns. So today, I sign off with these.